All right. Good afternoon, everyone. Here we go. Let's get started on today's video. All right. Today's video is about constant change or constant rate of change or slope, if you will. It's something that you all have seen in probably every single one of your previous math classes at LFHS, all right, or in high school. Okay. So we're going to look at, obviously, just how we always do, we'll look at it a different way, okay, and kind of try to introduce it in a different way. And then we'll dive into it. All right. So what I want you to do is use the first 2 points shown on the graph. So these two to find the increase in distance over the increase in time, and then repeat with these 2 points here as well. Make sure you simplify the ratios. Go ahead and try that. So I'm going to use these 2 points and then these 2 points. Go for it. Okay. I got for here. Up 60, because if you look at the actual how much is up out here, the scale goes up 60, and then I went over 1. So 60 was the distance. Okay, distance is the vertical, time was 1. Here we went up 120 and right 2. So 120 over 2, which is 60 over 1. What do you notice? They're equal. See that? Okay, I got 60 over 1 and 60 over 1. Okay, or 60, sorry, I should have used our units, 60 miles per 1 hour. All right. So the next question asks, because there is a constant rate of change of time to distance, the points fall in a line. For the car, what does the rate of change represent? Well, it's 60 miles per 1 hour. So it represents speed of the car, which is 60 m. That's how we're used to writing it, as 60 mph, miles per hour. This is also where you can write it, how we had on the first slide, miles. And then the fraction bar, when you're dealing with word problems, all right, I think of it as the word per. Okay, so 60 miles per 1 hour. All right. So what is this all? What's our discovery about? Can you interpret the line? So interpret the slope in physical context as a rate of change. Doesn't matter which point we use the first. If we're talking about a slope formula, and what's the difference between 0 and undefined slope? Okay. So obviously you've seen this in the past. Slope is rise over 1. Okay. How much we increase by how much we go horizontally. All right, there's a couple examples here that you can read over. I'm not going to read those to you. It's not story time, unfortunately. Okay, but let's talk about this example. So I skipped the first example because it was basically it just gave you the solution. All right, I just wanted to try one with you. If you want to look over that first example, go for it. So I'm looking at page 314 now, for those of us that have a book. All right, so I'm going to plot these two. It says use the graph to find the slope between the line passing through -3, -2, which is right here, and then 1, -5. So again, my slope, my rate of change is rise over 1. In this case, I'm going down. All right, when I go down left to right like that, when I fall, remember it should be negative. Let's see if I can get a line in there. Try to get a straight line going through there. That's a free-handed straight line with a stylus. Not too bad. All right. So when I go down 1, 2, 3 units. That makes it -3. And I go to the right 1, 2, 3. What is that? 4. 1, 2, 3, 4. Yes, 4. So the slope here should be -3 over 4. Now, there's a big discussion about where do you put the negative sign. This -3 over 4 is the same as just putting it right in front. It's also the same as putting it on the bottom. Now, I don't think you should do that. This is the preferred method. This is what you're going to always see, in your answers. Okay, so I would get in the habit of doing, throwing a negative on top. Why? Also because, guys, the negative refers to traveling up and down. Then we always go right. We always count right. Okay, if I'm plotting points, I always go up or down and then to the right. Unless I'm going backwards, I'm doing the opposite of what I would usually do. So I don't, I don't like to say the word always, but more times than not, we're going to go right. So a graph is a helpful visual aid. Okay. We can also just use 2 points to calculate the slope as rise over 1, my change in y values and over my change in x. The symbol delta, it's a triangle, it's delta. Okay, it stands for change in. All right, that's a very mathematical thing that mathematicians use. All right, so for this next slide, I want you to turn to page 317 because I really like the explanation that this offers before we get into the nitty gritty of slope. It gives you a real life example of slope. And we think about roofs. Okay, it says roofs are described in terms of their steepness or pitch. A 5/12 pitch means 5 inches of vertical rise every 12 inches or 1 foot of horizontal run. I notice the figures of the roof with that 5/12 pitch is the flattest of the 3 roofs, and the roof with the 12/12 pitch is the steepest. The roof with 6/12 is in between the other 2, steepest numerically. We can look at that. The 12/12 roof is steepest because it's the greatest rise of the 3 for the same run of 12 inches. Greatest rise, 5, 6, and now 12. As the roof gets steeper, the value of the slope increases. Intuitively, it makes sense for the greatest slope to be associated with the steepest roof. So if you think about all these lines that we graph as roofs, okay, and how steep they are, it kind of helps us. All right. I also think about it as, if I determine if it's positive or negative. So if I have a line like this, I'm walking up the roof. If I have a line like this, I'm walking down the roof. And when I think of down, I think of negative. So that's kind of how I think of the positive versus negative idea. That helps me determine, what symbol to use there if you're kind of unsure. Okay, so then, it gives them this real mathy definition. We've seen this m is y2 minus y1 over x2 minus x1. Okay. What I want to do is I want to look at letters A and B. Okay, we're going to do A and B together. Actually, here's what I'll have you do. Why don't you pause the video now, do A and B, all right, and then when you come back, I'll have it done for you here. Here's my answers for A and B. Remember, letter A was a positive slope. I got 3/5. Letter B was a negative slope because I'm traveling down the roof. I got negative 10/6, which I can reduce to negative 5/3. So make sure you're reducing. I want you to now try parts C and D. These are both special cases. All right, let's see if we can figure out what makes them special. All right, so for part C, you'll see that this is a horizontal line. In a horizontal line, I don't travel up and down any units. All I do is move left and right. So technically, I go up 0 and then right 3. 0/3, that means my slope is actually 0. If 0 is in the numerator, if 0 is on top, okay, then your slope is 0. 0 over any number is 0. It could be 0/10, it's still 0. This one's a little bit different. This is a vertical line, straight up and down. I go up 2 units, but I don't travel left and right. Okay, so it's 2/0. Well, I can never divide by 0. You're not allowed to do that. Since we can't divide by 0, we call that slope undefined. Okay, it's going to be our last slide for today, and then we'll head back to the class. This is just ways to think about, the different shapes of our slope. Okay, so if m is negative, you're going to get some sort of line like this, falling from left to right. Undefined means it's straight vertical. M is positive if it's rising from left to right, and m is 0 if I have a horizontal line. I kind of like this. It's kind of like a clock almost. It's kind of like a clock. In the clock, the top half of a clock. It's kind of interesting. I have negative, positive, undefined, 0. I don't know. I kind of like it. It's interesting little portrayal there for you. All right. We'll see you soon.